So calculating the E of the cell, and notice that is cell potential, not cell energy, but we can turn it into energy with another equation. To calculate potential of cell is actually really easy. It's easy to overthink, in fact. So the formula in this book is that the E of the cathode minus the E of the anode will give us E of the cell. So where do we get these numbers? Well, they come off of charts, so that's super easy. You just got to make sure you grab the right charts off the numbers. Here's a little trick, is that this is E reduction of the cathode, so these are E reduction values. And I know you're thinking, okay, so there's oxidation values. Okay, so because with the activity series, if you remember in the activity section, depending on who it's paired with, one reaction might want to go one direction and another reaction might want to flip and go in reverse. You know this because of equilibrium and stuff. So we list everything as a reduction potential, and that negative right there is how we fix that cell potential. In fact, some people, and you'll even see an example of this, what they'll say is oh, well, really it's the E reduction of the cathode plus the, and then in their head, they'll do this, they'll flip it in their head, and they'll do that of the anode. So sometimes it's confusing because you'll see a cathode plus an anode formula and you're like, but isn't it a cathode minus the anode? How can they both be the same? It's because they're flipping this and they're not saying it out loud. Or they are saying it out loud and it just isn't translating. So just want you to be aware, there are two ways to do that. And then besides that, it's just pulling the right stuff off the chart. So I have a chart pulled up over here. I really like this chart because it shows these values so that you're starting with something really positive up here at the top, like this fluorine. It's got that E value, it's like 2.8. It's really positive. And you'll notice as you look at the right-hand column, as you go downwards, you end up eventually getting to 0. That matches with hydrogen. And then you keep going down and you end up down there. Now, this should kind of make sense because you notice these elements at the bottom. These are the elements that actually are, they want to, like as written, what a reduction is saying is they want to gain an electron. This is showing an electron gain on the left. But lithium doesn't want to gain electrons. It really wants to give up electrons. So does potassium. On the flip side, if you look at the top, so fluorine, he's really close to having 8 electrons. And so fluorine actually wants electrons. So you'll notice up here that number is really positive. So all of these, if you look down, 2 electrons on the left, 2 electrons on the left, 3 on the left, on the left, on the left. Every set of reactions in here has electrons on the left. And again, that's to be really consistent. If we had tons of reactions left and right, it could be even trickier to follow what's going on with reactions. So we write everything as a reduction, meaning it's accepting and adding on electrons. And then once we do that, we're like, oh, well, if it's wanting to add on electrons, then it's going to be at the top of the chart. And if it isn't, it'll be at the bottom. And that's the one we're going to flip so that it fits what it wants to do. So let's find some numbers and we'll just show you how easy it is to work these. So if I can find copper, where is copper? It's right here. So here's copper and its value is 0.34. So you just write that out to the side. 0.34. And if you're wondering on units, these are volts. Let me go up to the top. See, in parentheses, there's a V. That stands for a volt. It's voltage. And then if we scroll on to the zinc one, here's zinc. So this one's value is negative 0.7618. So notice that this one is lower. And so what that means is that this one is the one that will essentially flip. Now, you don't have to write it as flipped. Just know that that is what's going on. And so this reaction, in fact, wants to have the zinc on the left, and it wants to have these guys on the right, and it wants to be like that. And so when you do that, like with other times that you do stuff with reactions, that's why we had the negative in our equation, because we're flipping that one. So E of the cathode, or E of the cell, is equal to, this is going to be our cathode because it was higher, and this is our anode because it was lower. So it's going to be 0.34 minus negative 0.7618. Or in your head, if you want to say, no, I'm just going to flip it, you can just say 0.34, but you have to use the other equation where you're just adding them. So if you're flipping the sign and then you're adding these two values together, you're just saying this. You'll notice that both ways get you the same equation. I like this way because I like just filling in equations. But some folks like the intuitiveness of doing it the second way. So we just say 0.34 plus 0.7618. And that gives us the E of that cell is equal to 1.1018 volts. And by the way, that is spontaneous. Positive E's are spontaneous. So that means that if you stuck that together, it would want to create a current that you could take advantage of. And then let's do this one. And pull this back over the chart. We're going to look up these ones. So where's our gold on the chart? And sometimes you have to look a bit. It should be lower. I'm not seeing it. Maybe you're seeing it. I know it's on the chart though. Oh, no, it's higher. Here's our gold. So our gold is 1.498. And then our manganese, now make sure you're grabbing the right one. We need the manganese that goes to MnO2. If I grab this one, you'll notice on the right-hand side, that makes Mn2+. That's not the reaction we want. This is the reaction that has MnO4 on the left and MnO2 on the right. There is more stuff in this reaction, and yeah, if you were doing all the half reaction balancing, you would need all of it. Like this is kind of halfway done for you, so that's kind of cool. So that is 0.558. Now, because this one is higher, this one is the one that is the reduction. It's going to be our cathode. This one is going to be our anode. And so again, E cell is 1.498. And then we're flipping this one. So the negative flips it. Because this reaction doesn't want to be like this. The Mn wants to be on the left. And these ones want to be on the right. And our arrow wants to be over like that. That's what that reaction wants to do. And it makes sense because now the electrons are on opposite sides. And so our value for that is 1.498 minus 0.558. So that's 0.9